Welcome to FMSP Online Revision. This session is for OCR FP1 and the topic that we're going to look at is Summation of Series. So we'll start by having a look at the specifications. So just 3 points here. First of all, candidates should be able to use standard results for sigma r squared, sigma r cubed, find related sums. Now be careful because sigma r squared we will get from a formula book and sigma r cubed we will get from a formula book, but sigma r we are meant to know is n over 2 upon n plus 1. So this one, as I say, you definitely need to learn. Second part says that we need to be able to use the method of differences to obtain the sum of a finite series. And in part C, recognise by direct consideration of the sum to n terms when a series is convergent and find the sum to infinity in such cases. So what we're going to do now is we're going to have a look at some exam questions which will draw out these points and hopefully enable you to be able, when you're doing the questions, to get as many marks as possible. So the first question, fairly standard question where you're asked to express sigma going from r equals 1 to n of 2r minus 1 all squared. You've got to express that sum in a fully factorised form. So when we do this, just bear in mind that what we're going to be using is the fact that 2r minus 1 all squared is 4r squared minus 4r plus 1. So when we find sigma of 2r minus 1 all squared, we can use this result, and in fact we can take the constant terms outside the sigma notation, and so we end up with the sigma 2r minus 1 all squared from 1 to n will be equal to this sum minus 4 lots of sigma r plus sigma 1. And all of these are being summed from 1 to n. So the first one, now this is where you need to go to your formula books and check carefully, but the sum sigma r squared will be n over 6 upon n plus 1 upon 2n plus 1. This one we're meant to learn, so we should know that sigma r is n over 2 upon n plus 1, and we should also be able to see that sigma 1 n times is going to be n. So we now need to simplify. So we have now got an expression, but of course it's unsimplified. So I'm going to start by simplifying the fractions. And then the next trick is always to look for common factors. So don't think about multiplying out the brackets, think about factorising. And if there are fractions, it's always a good idea to bring them outside the brackets at this stage. So I'm going to take a third out, and then I'm going to see that there is a common factor of n and nothing else. So inside my brackets I will now have, I've got a 2 and an n plus 1 and a 2n plus 1 for the first term. I have a 2n here, so I've taken the n outside, so that's alright, but just be very careful, you have taken n over 3, so we'll actually need to have a 6 here. And the same thing applies here, we've taken out n over 3, so we must have a 3 here. And again, just mentally just check by multiplying out if you're unsure. So the next trick is really to simplify what's inside the brackets. So we have n times 2n squared times the 2 here, so 4n squared. We have a 2n plus another n, that's 3n, times 2, which is 6n. 1 times 1 is 1, but the 2 outside brackets makes it a 2. And then we have a minus 6n minus 6 plus 3. So again, just continuing to simplify, we have 4n squared, 6n minus a 6n, so those will cancel out, and we have a 2 and a 3, which is 5, take away 6, which is minus 1. So we now have a quadratic, and hopefully you will recognise that quadratic as being a difference of two squares. So it's 2n all squared minus 1 squared, so we can factorise that as 2n plus 1 upon 2n minus 1. And we have our answer. So just having a little look at how we get the marks for this particular question. You will get up here a method mark for seeing that you've got 3 terms, and another method mark for substituting in the correct sum results, either because you've had to learn sigma r or you've used the formula book for sigma r squared. So you then get an accuracy mark if you have substituted those in correctly, and although we haven't simplified it yet, you will get an accuracy mark in the unsimplified form. You get a method mark then for attempting to factorise, and an accuracy mark if you've taken out this factor of n and you've ended up with a quadratic, any quadratic. You then get an accuracy mark if you have the correct quadratic and you've put it in a fully factorised form. So 6 marks. So we'll now have a look at another question which looks at the other aspect of summation of series, which is this idea of method of differences. So just looking at the question, 3 parts. We first of all have to show that we have a set of differences equal to 2r plus 1 over r squared upon r plus 1 all squared. We're then asked in part 2, hence find an expression in terms of n for the sum of this expression. And then in part 3, we're asked to find a sum to infinity. And just notice here that it's actually from r equals 2. So always have a good idea just to have a read through the question, and then what we'll do is we'll look at each bit in turn. So let's have a look now at part 1. So in part 1 there's only 1 mark for this, but it is on the other hand a show that question. So just make sure that you do actually show it quite carefully. So we'll need to subtract the fractions, so we'll take a common denominator of r squared upon r plus 1 all squared. So on the numerator we'll have r plus 1 all squared minus r squared. And of course if you multiply out these brackets, you'll find of course that the r squared term cancels out, and we're left with the required result. So we've got 2r plus 1 over r squared upon r plus 1 all squared. And just 1 mark. In part 2, we're then asked, using this result, because it says hence, find an expression in terms of n for sigma r equals 1 to n of this 2r plus 1 over r squared upon r plus 1 all squared. So we are going to use this form so that we have differences. It's the method of differences, so you have to have this, it has to be one term minus another. So we'll start by taking different values of r. So if r is equal to 1, we would have 1 over 1 squared, which is 1 over 1, minus 1 over 1 plus 1 squared, which is 1 over 2 squared, which is 4. So all I'm doing is I'm substituting my value of r into this expression here. And then I'll do that for a couple more values. So r equals 2 will be 1 over 2 squared and 1 over 3 squared. And then when r equals 3, it will be 1 over 3 squared minus 1 over 4 squared. And at that stage now, you'll probably see what's happening, but you should just go through and write out a couple of terms at the end to make sure that we show all our working. So when r equals n minus 1, we'll have 1 over n minus 1 all squared and 1 over n squared. And then when r equals n, we'll have 1 over n squared minus 1 over n plus 1 all squared. And as I say, it's sometimes called telescopic method because of course these terms now you can see are going to cancel out. So this term would cancel out with that term, this term with this term. And the only ones that aren't in this case is this first bit and this last bit. So what we've got is that the sigma from r equals 1 to n of 2r plus 1 over r squared upon r plus 1 all squared is equal to 1 minus 1 over n plus 1 all squared. So just again looking at the marks that you get for this, you get one method mark for writing out these first two terms and the last term. You get an accuracy mark if you've written out all the terms, a method mark for showing correct cancelling, and an accuracy mark for the correct answer at the end. So this is our answer, 1 minus 1 over n squared. So we've still got another part to look at, so that's part 3, which is where we're asked to find the sum from r equals 2 to infinity. So just let's have a little look here. We have found in part 2, this is what we found, that sum from r equals 1 to n was 1 minus 1 over n plus 1 squared. So the first thing that we need to realise is that if we're going to sum this from r equals 1 to infinity, then as n tends to infinity, this term is going to tend to 0. So the sum to infinity is going to be equal to 1. So as long as you can see that as 1 over n plus 1 all squared, this bit will tend to 0 as n tends to infinity, as n gets bigger and bigger. So we have now got the sum from 1 to infinity, but of course we're asked to find the sum from r equals 2 to infinity. So we need to see that actually we don't want the first term. When r equals 1, that is just your first term. So we need to take the first term away. So let's just check from what we did before. The first term is when r equals 1, so it's going to be 1 over 1 squared, taking this away, which is just going to be 1, minus 1 over 2 squared, which is a quarter. So it's going to be 1 minus 3/4, which is 1/4. So in this particular case, as far as the 2 marks are concerned, you've got 1 mark for getting the sum to infinity, and you've got 1 mark for finding the sum from r equals 2 to infinity, a quarter. So we'll end this session here, and it's just really a matter of reminding you to get as many questions done as possible. That's always going to be the best way to revise.